All right, here's your first FEA, finite element analysis training. Notice that I am in Inventor 2026. You will need to do this in 2026 because that's what the model is. My apologies. I set this course up for 2026 thinking that that's what we would have, and we don't. So you will need to go to VMware and do the design 2025 portal. I think I've got that so you can see it somewhere, but I'm not sure where. Okay, so here it is right here. You're going to go to the Design 2025 portal to get Inventor 2026. All right, and when you open up the first FEA file, let's see what it says to do. It says to open it up, save it with my own name and file name and initials. And I'm going to do a stress analysis and just find out what's going on. And then I'm going to change my part until my stress analysis meets a certain condition. Okay, and that's what I'm going to show here. Once you've done that, you're going to go to the discussion board and enter it. And I'll make a new video about this one, okay, with what to do with that. So here we go. Here's my part. And in Inventor, you go to 3D model and stress analysis, or you go to environments. Nope, you don't go there anymore. 3D model and stress analysis. Okay, so I'm going to double click on that. Actually, that was a single click, and all this comes up, and I want to create a study. When you click on it, it shows up. It's a static, remember, it's static equilibrium. This is a vector problem. So you can just click OK. And then we want to check and make sure that we're doing the right material. It's assigned as aluminum, and that's what we're going to use. Later on, we might change that to see if it does better or worse with other ones, but we're going to use this original material. Then I have to say, how is this fixed in space? What's holding it in place? Because if it's just hanging by a thread somewhere and I hit it, it's going to go all over the place. So I'm going to go over, use this nav cube, and look at the back, and that is going to be firmly attached to the wall. It's fixed, left click, along that entire surface. Click. Okay, so that thing is firmly against the wall. Now, it says to add a 500-pound force downwards. Here are my forces. I can also do pressure bearings and all these other things, but I'm just going to go force. And I zoom in on this. That's my scroll wheel. And I put it right on that little piece sticking up. That's there because that's where the force is going to hit. And it's very small, so it doesn't affect the stresses at all. And look, it's a vector. It's an arrow pointing down, but I don't know the magnitude until I come and type it in. So I'm going to type in 500 pounds. So in Inventor, it doesn't make this longer or shorter. It just knows what the value is. So there I just double clicked on it, and it lets me know it's 500 pounds. And then I'm ready to go. Once you have it fixed in place and you've applied some sort of force, you're ready to simulate. And I'm going to go ahead. No constraint. What do you mean there's no constraint? Somehow I lost my constraint. Fixed along the back. There we go. Oh, I forgot to click OK when I did it. There we go. So if it's not stuck against something, it won't run. So simulate, run, And what's happening, this is all going on other, and look, comes up. Blue and green are good. Red is bad. I don't really see much red here. 57,000 pounds per square inch. That's the maximum stress. Okay, let's see what the maximum displacement is. Click, double click. Ooh, 0.2994 inches. It's actually going quite a bit. And the safety factor, is less than 1. So I got a little bit of a problem there. But I'm going to note those in a spreadsheet. Just open a spreadsheet and say what you've done. 500-pound force down gives me displacement of 0.2994 and safety factor of 0.7. So you can just note it. Okay, I'll show it to you right now. I'll do an example for you. So there we go. And so this is my load, max safety factor, max displacement. So that was 500 down, what was that, 7? 0.7. And that's actually my minimum. And that's got to be over 1. But we'll get there. That one should say minimum. Is 0.7, so that's no good. And this was 0.299. That's a lot. But now I'm going to go 500 down plus 100 right. And let's see what happens. So now I have to come back and add one. Here's my fixed. Added, oops, I didn't want to fix that. Force sideways of 100. So this is going to make it even worse, right? Now I'll simulate it again. And now I've got, it's even worse, my displacement 0.936. Oof, not so good. And my safety factor is probably even worse. 0.45 now. That is not that great. And right now, I'm going to say that I know I'm going to have a certain bar height and bar width, because next I'm going to need to change those. So I've got that in my thing here now. Okay, so I can finish my analysis and find out. Here's my parameters. If they're not showing up for you, they're under this little triangle, parameters. And when I double click on it, my bar vertical bar height is 2 and 0.5. 2 and 0.5. 2 and 0.5. So that's what this thing is doing, and it's not very good. And you'll be able to see, what do we want to do? We want to make sure that these are over. So I'm going to format conditional. If that is less than 1, then it's red. And if it is, add another rule, greater than or equal to 1, then it gets to be green. So the next thing it says to do is adjust these heights and widths to try to make it a little better. So I can come over to my parameter chart and I'm gonna guess maybe a 2.5 and maybe a 0.62. Oops, I'll add an eighth, 0.625. So when I go back into my stress analysis again, unless I create a new study, all my stuff stays there. So that's good. I can just run it now. Here's my run my study. And I've got a displacement of 0.3999 and a safety, 0.85. Well, I made it partway there. So here I've got this same thing here, 0.85, and it was 0.299 again, I think. .399. And that was a 2.5 and a 0.625. So now give it, you would give it another try until you get this number to be green. And then you're going to report all that stuff into the discussion board. I'll make another video about what we're supposed to do with this data once you have it right. What I mean by right is once this turns green. Okay, so you're going to make another adjustment and another adjustment, or maybe just to one of those. Okay, and we'll talk about in class about how you might decide what to do. But that is your first thing to do to learn how to do finite element analysis.